Hi, I wanted to control a hobby project using a voice assistant, and I found a lot of great blog posts and YouTube videos that explained a portion of the problem, but I wanted to create a tutorial that gives you all the info in one place, that walks through the entire problem end to end, step by step. So that's what I'm going to do here. I'm going to show how to control this Raspberry Pi Pico W using this Amazon Echo. Let's get started. Let's look at our project at a very high level. We need to make 4 components to get this whole thing working. We're going to speak a command to an Alexa device, and Alexa needs some sort of application to tell it what that command means and what we want Alexa to do in response. And that application is called an Alexa skill. Our skill is going to be very basic. It's just going to convert a phrase into a sort of function call. Alexa is going to send that call to a back-end system called AWS Lambda. Lambda is like a microservices platform. You can write arbitrary code and put it into a Lambda function, and that Lambda function lives on an Amazon server, and you can call it and execute it whenever you like. Our Lambda function is also going to be very basic, and it's just going to receive the call from Alexa and publish it to a server. So this server is another AWS service called IoT Core. IoT Core and the Raspberry Pi Pico talk to each other using an IoT protocol called umqtt. I don't know what that stands for, but that's what we're going to use. The Pico is the client and the Core is the server. And well, that's the whole system at a very high level. So let's start putting it all together. So step 1, we need to make an Alexa skill. So you need to go to developer.amazon.com and you need to open up an account here. You can open up a free account for hobby purposes. We're going to go to Developer Console and Alexa Skills Kit. I already have a few skills in here. We're going to make a new one. Let's click on Create Skill. Let's give it a name. Let's just call it Raspberry Skill. As far as locale, I think this is essentially which language and dialect you want it to use. I want it to use American English. And I'll go to Next. What type of skill do you want to create? I'm going to do Other. And Custom is already selected here. I want a custom skill. We scroll down to the bottom here. I'm going to use Python for this one. And then for hosting region, I'm on the West Coast, so I want my skill to be based in Oregon. It just reduces latency and makes everything work faster and more smoothly. And go to Next, start from scratch, and click Next, and OK. Raspberry skill, American English, Python, West Coast, custom. Yeah, let's create the skill. And this is going to take a few minutes. So we'll just have to wait. Okay, our skill has been created. Now we need to configure it to actually do something. So there are a couple different parameters we need to set in any case. And the first one is this invocation name. Now the skill has a name. We called it Raspberry_skill. But this is, the invocation name is like the actual words you'll speak to Alexa to invoke the skill. So that'll be something easier to say, like Raspberry Demo. Let's call it Raspberry Demo. Next up are the functions that our skill can actually request or trigger. And those are called intents. And just like our skill name has a corresponding invocation name, our intents are going to have a corresponding list of phrases that can trigger them. So the intent might be called like turn on the light intent. The samples will be a list of different phrases like turn on the light, turn the light on, make the light turn on, or just light on, something like that. Slots are like arguments, parameters that you can pass to the intent. Something I'm not going to use here today. But for hypothetically, if we were making like a smart thermostat, you could say, hey Alexa, tell smart thermostat to set the temperature to 70 degrees. And that would be the invocation name and the sample for the intent and a slot to the intent. So let's actually set some of those values. We can go over to invocations and set our skill invocation name here. We can go to interaction model and create some intents here, but we can also just go to JSON editor and do them both at the same time. Now this editor here in the browser is really buggy and really annoying, so I'm not going to use it if I don't have to. Instead, I've already made all my modifications here in VS Code, and I'm going to copy and paste these over. And so let me see what I actually changed. I changed the invocation name. I set it as Raspberry Demo. And there are several intents that are built in: cancel, help, stop, hello world. And as you can see, hello world intent has a lot of different samples that can be used to trigger it. And then I created two new intents: turn off LED intent and turn on LED intent. And each one of those intents has two different phrases that can trigger it: turn on the LED or turn the LED on. And they'll both call the same function. So those are all the changes I need to make. Let's save this. And now let's build our skill. And this is going to take several minutes, 3 or 4 minutes usually. While we're waiting for that, let's look at the back end. So this JSON basically defines our front end. It's a list of all the, the invocation name and all the actions we can take. But when we say one of these samples here and we invoke the hello world intent, what is actually getting executed? Where is hello world intent? Where does that code live? Well, it lives here in the code tab. Currently, we have a Lambda function, .pi, here, and this is, it's a Lambda function, but it's not an AWS Lambda function. It's an Alexa Lambda function. It does the same thing, but it's rather limited. As far as I understand, you can't, connect this to other AWS services. But we have a hello world intent handler, and it doesn't do much. It just produces speak output equals hello world. So Alexa is going to say that in response. So the way Alexa skills are set up is the front end calls a back end, and it does so through this endpoint. We specify an address for the backend function that we want to execute. And currently, this address points to that Lambda function .pi. We are going to create a new Lambda function on AWS that has a lot more options, a lot more possibilities, and we're going to redirect Alexa to talk to that backend. But by now, I think our skill is built. Let's test it out. If we go to the test tab and we turn development on, we can type a prompt in here and see how our skill will respond. So I don't have to say Alexa because it already knows that I'm addressing it here. I can just say, tell Raspberry Demo to say hi. And it gives us this output. This is the JSON output that it sends from the front end to the back end. And there's a lot of info in here, but there's only one little piece we actually care about, and that is this bit at the end. It's sending a request with an intent that has a name equal to hello world intent. So it recognized that say hi is triggering the hello world intent. It's sending that to the back end, and our back end is sending back to the front end this response: I want you to speak the words hello world. I can try one of the custom intents that we created. Tell Raspberry Demo to turn on the LED. Produces another request. And this time, the intent is recognized to be turn on LED intent. And we haven't specified any functionality for that, so there's a catch-all in there. And it's going to respond, you just triggered, turn on LED intent. Cool. So I'm going to try to run that skill we just wrote on this Alexa device right here. I'm going to open up the Alexa app. I'm going to go to More, Skills and Games. I'm going to scroll down to the bottom. Your Skills. Scroll over to the right. Dev. And then down here at the bottom, Raspberry Skill. Oh, it's already enabled. If this is not already enabled, then you need to click Enable there. Okay, so let's turn this thing on. Alexa, tell Raspberry Demo to turn on the LED.
You just triggered turn on LED intent.
Okay. Alexa, tell Raspberry Demo to say hi.
Hello world.
Cool. So that's all the same functionality that we had here on the test page. So I think our Alexa skill is working. So now we can move on to part 2. Let's go over to aws.amazon.com. You will need to open a separate account here for AWS. I'm not sure why, but that's how it's broken down. And this is your front page. We need to create a Lambda function. And this will be an actual AWS Lambda function instead of an Alexa Lambda function. And same name, but different. So you can go in here and just type in Lambda. And it's this yellow Lambda right here. Let's click on that. Now, I already have a couple made from previous projects. Let's create a new one. Oh, before we do that, check up here. I'm on the West Coast, so I want to use Northern California. You want to pick the region that's physically closest to you for the same reasons, to decrease latency and improve overall smoothness and performance. So let's create that function. Author from scratch. Let's create a name for it. Let's call it Raspberry Lambda. Now you can use whatever language you want, but I'm going to use Python. And I'm not going to configure any of these other settings. And we can create the function. Okay, we've got a function. It doesn't do anything yet. Let's fix that. So right now, all it does is we call it, when you call this Lambda function, it calls this Lambda handler, and it returns hello from Lambda. That's not particularly interesting. I've already written up a better function. Let's open that, lambda.py. Copy and paste that in here. Okay, so I've only added a couple of lines, but they're significant. First of all, something to understand is that when we're going to hook up our Alexa skill to trigger this Lambda function, and when we call the Alexa skill, we showed that it produces this big giant file right here called an event, and that event contains request intent name, and that's the name of our intent right there. So our Lambda function is going to receive that event, and it's going to have within it a request intent name, and that request intent name is going to get dumped into the payload for this function, into response, and we're going to print the response. It's going to get printed to a topic called Raspberry Demo topic, and that is an umqtt topic that will get published to our Raspberry Pi. Let's see what else in here matters. I added in these couple lines right here. It's going to return, this return chunk is going to get sent back to Alexa. So there are a couple things you actually absolutely need in here, otherwise Alexa will fault out and be very unhappy. The essential one is this right here, should end session true. Hey, Alexa, we're done. There's nothing else to do. You can, go back to sleep. Another thing is response output speech okay. So when we add that in there, Alexa is going to send the event to Lambda, and Lambda is going to return to Alexa, say okay, just to let the user know that you're done. But that's it. That's all that we need here. We're just going to pass that intent name through and publish that to our Raspberry Pi. So now that we've added in this code, we can click deploy. And it's deployed. Now we have to actually connect the two together. We have to add a trigger. Okay? So let's click on add trigger, select a source. It's going to be the Alexa type. And we need a skill ID. So let's go back to Developer Console. Let's go back to our skill under build. Endpoint. This is our skill ID. This is just a unique number within the Amazon ecosystem that identifies our skill. Let's copy that. And let's add that as our skill ID. And save that. Okay, cool. So we have to connect this in both ways. So now let's take this ARN, which identifies our Lambda, copy that, go back to Alexa, and let's clear all four of these existing ARNs out. These ARNs point to that code, that built-in Lambda function that we're not going to use. So let's clear that out. And let's add in our new Lambda function that is capable of talking to the Raspberry Pi, and click Save. And once again, it's been saved, but we have to rebuild it before it will actually do anything. No, that's not the button I wanted. Build. Let's rebuild. Okay, this is going to take several minutes again. Let's go back to our Lambda. So while that Alexa skill is rebuilding, let's add in the next piece of the puzzle. Let's open a new tab and go to aws.amazon again. This time we're going to search for IAM. Now this is a policy system. It handles security policies, and we have to define a security policy that allows our Lambda function to publish to IoT. By default, it's not allowed to do that. So let's go over here to policies, and let's create a policy. Let's see, select a service. This is a policy that lets it connect to IoT. So let's type in IoT, and just plain old IoT. Let's click that. And then the actions that are allowed. Let's see, we want to be able to publish to IoT. Okay, write, publish. That's what we want. Let's select that. Which resources? All resources. If you have a more mature idea of how your system's going to work, you could specify specific resources, but for now, we're just going to leave it at all. I don't have any other devices that I'm worried about conflicting with. So next, let's make a name. Let's call it Raspberry IAM policy. And that's it. We're done. Okay. Now we need to go back to the Lambda, and we need to connect the Lambda to that policy. So let's scroll down. Where is it? Permissions. And then over here in execution role, edit. Scroll all the way down. Here at the very bottom, there's a blue link. View whatever this thing is on the IAM console. Click that. It's going to open a new window. Now, permissions, policies. Add permissions, attach policies, and let's search for the Raspberry IAM policy that we just created. We're going to select it. Don't click on it. Select the checkbox and click Add Permissions. Policy was successfully attached to role. Great. Okay, we can close that out. And we can cancel out of this. And we're back at our Lambda. Okay, so we just gave the Lambda function permission. It was already able to receive a command from Alexa, but now it has permission to publish the name of the command it received to an IoT device. But we haven't set up the IoT device yet, so that's part 3. Let's see. Let's go up here to IoT core. Connect the devices to the cloud. That's exactly what we want to do. Okay, down here. Where is it? Is it security? It's security. Click on security. Click on policies. So the policy we just created was for the Lambda function, giving the Lambda function permission to talk to IoT. Now we need a security policy that gives IoT permission to talk to our Raspberry Pi. So let's create a policy. Let's call it Raspberry IoT policy. And we want it to be able to do, down here at the bottom at policy document, we want it to be able to do 4 things. So let's add new statement. We have 4 things here. Allow, connect. We want it to be able to connect to devices. We want it to be able to publish to devices. We want it to be able to receive from devices. And we want it to be able to subscribe to devices. And for each of these things, we want to give it global access. And create. That's it. That's all we have to do for that policy. Now let's create an IoT device. Let's go over here to manage all devices. Things. I already have a thing created. I want to create a new one. So let's click create things. Create a single thing. Let's call it Raspberry IoT device. I'm not going to bother to configure any of these things. I don't even know what a shadow is. Let's click next. Auto-generate a new certificate. Yes, we want to do that. AWS talks to devices using SSL certificates, and those SSL certificates are connected to this Raspberry IoT policy that we just created. So select that and click on Create Thing. So here are our certificates. This is the only time you can download the key files for this certificate, so we should do that now. Let's download everything. Okay, and then we are done. Okay, so far we have created an Alexa skill that can turn our spoken command into an intent, which is basically a function call. And we've hooked up a trigger to a Lambda function that can receive that intent and publish it to an umqtt topic. And then we created an IAM policy that gives the Lambda function permission to publish to an IoT topic. And then we created an IoT server to hold that topic. And we created an IoT policy to give that IoT server permission to communicate with an external device, which will be our Raspberry Pi Pico. So everything's built. All 3 of these components are connected. Let's try them out. Let's go back to the Lambda function here. And we said it was going to publish to a topic by the name of Raspberry Demo topic. So let's highlight that and copy it. And then let's go back to IoT. On the left, let's click on umqtt test client. Let's subscribe to a topic and type in our topic name and click subscribe. So down here we have a form and a publish button. And anything that gets published on the topic that we're subscribed to will show up here at the bottom. So we can click publish, and this phrase just got published here. Cool. So now I can say, Alexa, tell Raspberry Demo to turn on the LED.
Okay.
And that's it. As I said, Lambda tells Alexa to respond with OK, and then it publishes the phrase turn on LED intent to our topic. So that's the whole, Amazon internet pipeline. That's everything we need. Now all we have to do is create a Raspberry Pi Pico device to actually connect to this topic and read from it and respond to it. So to manage our Raspberry Pi Pico, I'm going to use a free application called Tawny. Now, I usually work in C++, but I haven't been able to find a C++ umqtt client for Raspberry Pi Pico, but I have found the umqtt client for MicroPython. So that's what I'm going to use here today. First, I'm going to hook up my Raspberry Pi Pico and press boot select while plugging in so I can put it into boot selector mode. And after connecting that, I can go down here to the bottom right, click on this, and I have the option to install MicroPython. So let's click on that. So Tawny has recognized that I have a Raspberry Pi Pico connected. It's the only one. MicroPython family is going to be Raspberry Pi 2 version. The variant is going to be Pico W since I'm connecting this over Wi-Fi. And I'm going to use the most recent version, 1.22.2, and I'm going to click install. And so now it's downloading and installing the MicroPython runtime environment on the Raspberry Pi Pico. This will take a moment. Okay, done. Let's close that. Now let's go down here to the bottom right again, click on this again, and let's say connect to the Raspberry Pi. Okay, so we're connected to our Raspberry Pi Pico. It's empty right now, so let's put some stuff on it. Let's see, I'm going to go downloads. Let's copy over all of these certificate files that we downloaded from the AWS IoT core when we created that. Upload. And then I'm going to create several other files. First, we need a new directory called lib. And in that, we're going to create a file called device.py. And this is just the hardware control code, which is pretty trivial because it's just telling the LED to turn on and off. I had a third intent here that I forgot to add to the Alexa, but hopefully you'll still get the idea. Paste that in, save it. Make another called simple.py, and this is the older version of umqtt.simple that I have saved. And then let's make one called keys. This is going to be all of the key info. So of course you need to add in your Wi-Fi information here, and you need to copy in these file names. And this is going to be the private key, the certificate, and the CA1. CA1 is actually not going to change. So copy in your private key file name, your certificate file name, and then you need your AWS IoT endpoint address. We need to get this from the IoT page. So let's go back there. Where is that? That is settings. Settings. Okay, right here, endpoint. Let's copy that. Let's paste that in there. And this is just my endpoint. Yours will be different. Okay, and last thing of all, we need to create a main. And let's throw in my main.py. And so this hopefully is fairly straightforward. I have a couple of setup functions here. The actual programs down here. First, we're going to initiate our Wi-Fi hardware. Then we're going to run an infinite loop, and we're going to connect to the internet, update to network time, set up our MQTT client, connect to our MQTT server, and then start listening forever, as long as Wi-Fi is connected. If Wi-Fi ever breaks down, then we go back to the beginning and reconnect to the internet. So a couple things to explain here. One, as soon as you connect to the internet, you need to update your Raspberry Pi Pico to internet time. It took me a while to figure out why that line needs to be there. That's because AWS uses SSL security certificates, and security certificates are signed and dated. So there's a specified beginning time and a specified end time for the validity of the certificate. When the Raspberry Pi boots up, it doesn't have any non-volatile memory, it doesn't have a persistent clock or battery backup, so it thinks it is midnight, January 1st, 1970. And the certificates that I just created will not be valid for another 54 years. So it won't let you set up the MQTT client unless you include that network time protocol update. Next up, let's see, what else did I want to explain? The listen function that we call here, that just runs forever. In here, originally, my hobby project didn't use AWS. It used an MQTT server run by Adafruit for free. And that system didn't use SSL. It used username and password. And I could just connect to it, and the connection would stay alive pretty much forever, for days and days and days. The AWS system, the connection dies if it's stale for too long, if it's stagnant and unused for too long. So now I publish a message to the MQTT server that isn't used for anything except to keep the connection alive, and I publish that every 30 seconds. Let's see, is that it? I think that's it. That's all I wanted to. Oh, one more point. Unfortunately, the umqtt.simple library, I don't think it has the ability to check whether or not the MQTT client server connection is still active and alive and valid. There is a wrapper class called umqtt robust, which claims to do that. I tried it. It wasn't working for me. It would be really great if this while loop here could check that Wi-Fi is connected and also the MQTT connection is still alive, but I don't really have that ability right now. If anyone knows how to do that, please let me know. I would be so grateful. But this is all of our code. This is everything. Let's save this and let's run it and see what happens. Connecting to Wi-Fi. This takes a few seconds. Connecting to MQTT broker. This takes a few more seconds. And we're connected and we're listening to the Raspberry demo topic. So let's test out Alexa again. Alexa, tell Raspberry Demo to turn on the LED.
Okay.
And there we go. We received a message from IoT Core that says just turn on LED intent. And our callback that we set up in the setup function, we provided this callback, MQTT callback. This function is right up here. It receives a topic and our message, and it prints out the topic and the message. And it checks if we have an attribute in the device folder, or the device file called message string, then let's call that message string as a function. And we have, oh, I can't do it without stopping it. In device.py, we do have a function called turn LED on intent, and it turns the LED on. And so that's everything. Okay, so, I mean, here we are, we're done. We set up an Alexa skill and a Lambda function and an IoT core server. And then we set up an umqtt client on our Raspberry Pi Pico W. And yeah, so now we can do this. Alexa, tell Raspberry Demo to turn on the LED.
Okay.
Alexa, tell Raspberry Demo to turn off the LED.
Okay.
That's it. That's all it does. Yeah. Hopefully you can make a device that does something more interesting than that.